Today we are going to learn AVL tree deletion. So there are three kinds of deletion when it is on right hand side. These are R0, R1 and R minus 1. And if it is on left hand side, so these are L0, L1 and L minus 1. So when it is R0, when it is R1, when it is R minus 1, we will learn today. Today we are going to learn R0. So as AVL tree is given, so first we cross check the balancing factor. With 24 because there is no child, so 0. 7 there is no child, so 0. 18 there is one child on left hand side, so plus 1. 23 there is one child on right hand side, so minus 1. 60 there is no child, so 0. 54 there is one child on right hand side, so minus 1. 20 there are two child on left hand side and two child on right hand side, so equal, so 0. 46 we are able to see there are 3 levels on left hand side and 2 levels on right hand side, so plus 3 minus 2, so plus 1. So this tree is balanced, there is no problem in it. As we know in AVL tree, if balancing factor are 0, plus 1, minus 1, then we can say the tree is balanced. Now what we supposed to do, we need to work on deletion. And suppose if we are deleting 60, then what will happen, we will see here. So we will draw the same tree here and we will not put the 60 node. So I am drawing it here, same 46, 20, 54, 18, 7, 23, 24 and 60 I am not keeping because I have deleted 60. So now after that we will see what is the balancing factor of this tree now. So 24 because there is no child, so 0. 7 there is no child, so 0. 18 one child on left hand side, so plus 1. 23 one child on right hand side, so minus 1. 22 levels on left hand side, 2 levels on right hand side, so plus 2 minus 2 0. 54 there is no child, so 0. 46 here we will see there are 3 levels, here is 1 level, so plus 3 minus 1, so plus 2. So now we are able to see because balancing factor is plus 2, so tree is not balanced. So now we have to do the balancing of the tree. So here one important thing is there, we need to suppose the root node as A and the next to the root node as B. We need to suppose the tree root node as A and next to the root node we have to suppose B. And based on the degree of that B, we need to choose that which rotation we need to do after deletion. Because the B degree is 0, so we will go with R0 rotation. Because here B degree is 0, so we will go with R0 rotation. Why R? Because we have deleted from right hand side. So R0 rotation. Rotation is R and it is 0, 1 or minus 1. It depends upon the balancing factor of this B node which is nearby to the root node. So R because we have deleted right side node and 0 because the balancing factor of B is 0. So we are going with the R0 rotation. Now what we will do? We will do R0 rotation. And because it is R, as we were doing in insertion opposite, when it is RR then we are going to shift left hand side, but here it is R0 rotation and deletion. So because it is R, so we will shift on right hand side only, not left hand side. We will shift the right hand side because R0 rotation is there, so we will shift the tree right hand side. From the node B, because based on the degree of the B node only we are choosing the R0 notation because we have deleted the node from right hand side, so R, and based on the degree of B we are choosing R0 rotation. So because R0 rotation, so we will shift the entire tree right hand side and we will make 20 that the B node as a root node. Based on the B factor, balancing factor, we are choosing the rotation, so we will move the tree based from the B. So we will make the B node, that is 20, we will make as a root node. So what we will do? We will make 20 as a root node. So 46 will come down and 54 will come down and 18 will come over here and 7 will come over here. Till now it is okay. 46, 54 will come over here, 20, 18 and 7 will come over here. So we have to follow the binary search property. So if root is 20, so left hand side less than the root and right hand side more than the root. Now we have to see these two nodes are left, 23 and 24, because they are now more than the root node, because now root node is 20. Initially it was 46. So because it was 46, so on left hand side it is okay, but now root node is 20. So left hand side it is not okay. So we need to place it on the right hand side. So 46 is the root, next root after 20, 46 is the next root, and 23 is less than 46. So it will come on left hand side of 23, because right hand side already one node is there. So we will go with left hand side. And now after that, what is that? 24. So 24 is more than 23. So it will go on right hand side of 23. Now we will cross check the balancing factor, because rotation is done based on the B. R0 notation balancing factor, because right hand side we have deleted. So R, the B factor is 0. So R0, because we are doing the rotation based on the B. So we are rotating it right hand side and make B node like 20 as a root node. So we have done this all. And now we will see the balancing factor. 24 is there is no child, so 0. 54 there is no child, so 0. 23 there is one child on right hand side, so -1. 46 there is one child, no, 46 two levels on left hand side and one level on right hand side. So +2, -1, +1. Again we will see 24 0 because there is no child, 54 0 because there is no child, 23 there is one child on right hand side, so -1, 46 two child on left hand side, or we can say two levels on left hand side and one level on right hand side, so +2, -1, so +1. 7 there is no child, so 0. 18 there is one child on left hand side, so +1. 20 there are two levels on left hand side and three levels on right hand side, so +2, -3, so -1, that is B node. -1, that is B node that come from here. So now we are able to see after R0 rotation the tree is balanced now. So this tree is balanced. So in this way we can do the R0 rotation, and L0 rotation is mirror image of this. And if we delete the any node from left hand side, and if we see the degree is more than +1, -1 and 0, then we will do the based on the B factor 0, 1 and -1, we will do the left side rotation. So in that way, in the similar way, we can do the L0 rotation. As in R0 we rotate the tree right hand side, so in L0 rotation we will rotate the tree on left hand side with the B node,